In the previous movie, we created some custom attributes to enable us to raise and lower the palm, as well as roll it from side to side. In this movie, we'll clean up our hand rig and connect it to the rest of the body. Start by opening the file Character Rigging, Part 31 Start, or by using your own file from the previous lesson. Before we begin cleaning up the hand rig, notice that we missed adding length attributes to all our finger joints. Like the other limbs, we'll want this squash and stretch functionality. However, unlike the other limbs, we're going to assume that if the animator wants to elongate a finger, they'll want to elongate the entire finger and not just one section of it. Create a length attribute on the left pointer control with a minimum value of 0 and a default value of 1. Using the set-driven key window, load the control curve as the driver, and the second to fourth compound control joints as the driven. Key the length attribute to the joint's translate x values. Now set length to 0 and zero out the value of each joint's translate x value, then set another key. Open the graph editor with those three joints selected. Select their translate x attributes and set the tangents to linear. Set the post-infinity interpolation to linear as well. Now we just need the geometry to scale accordingly. Select the three pieces of pointer finger geometry and open the node editor. Show the connections. Create 3 multiply divide nodes. Rename them left pointer normalized div 1 through 3. Set their operation to divide. Now middle drag the pointer finger's second to fourth orient joints into the node editor. Feed the default translate x value of each of the 3 joints into these nodes. And divide them all by their default scale. Then pipe those scale output values into the respective geometry's scale x values. The finger now mostly stretches correctly, except for the first geometry section. This is because the geometry's pivot is slightly off the joint, a side effect of the straight joint we added in part 30. You can easily fix it by snapping the pivot back to the finger's base joint. Repeat the last few steps for all the fingers. In the interest of time, we've included a scene file where this is already complete. The next thing we'll do is connect the hand to the arm. First group everything related to the hand in a left hand group and parent it to the EMA root transform control. Next, group everything except the control hand and control group into a do not touch group. Remember that both the control hand and result hand are parent constrained to the left hand base const joint under the palm's pivot locators. So if we place these locators into a group named left-hand cons group, whose pivot is centered at the wrist, then parent constrain that group to the arm's left-hand result joint, it should move the hand along with the result arm. This almost works, except the IK handles in the left-hand straight handle group are keeping the fingers from moving. Let's fix this by parenting this group to the left-hand cons group as well. This takes care of the basic parenting, but when we try to use our palm raise and side roll attributes, the hand breaks from the arm. That's not very good. We need the arm to stretch along with the palm. It's currently parent constrained to the result arm. Delete this constraint and create a new one from the left-hand base cons joint instead. The arm moves with the hand. Next, create a pair of custom attributes on the left arm settings control to toggle the visibility of the FK and compound hand controls respectively. As in previous lessons, use the connection editor to connect each of these to their respective control's visibility attribute. Let's turn our attention to our rigging checklist. The controls are already quite straightforward and easy to use. Next, we'll need to lock and hide attributes we don't want touched. Start by locking and hiding all the attributes on the left-hand base control joint and left-hand control group. Next, expand the control pinky joint chain. Then lock and hide all the attributes for every compound control joint, since we don't want animators confusing them with the FK controls. We'd like to lock and hide all the attributes on the straight joints, but we can't. This is because locking the rotate attributes would break the functionality of our IK handles. Thus, we'll just hide the rotate attributes first, then lock and hide the rest. The end joint poses a similar problem, but it's the translate attributes that need to remain unlocked. Next, lock and hide the FK fingers' translate, scale, visibility, and radius attributes as usual. Repeat this for all the fingers. We'll also lock and hide the transforms and visibility of all the compound hand controls. Next, add the hand's geometry to the geo layer. And the result joints to the result skeleton layer. Finally, we need to make sure our hand's transforms work in tandem with the EMMA root transform control. As you can see, moving the root transform causes a double transformation on the palm. So let's turn off the left palm geo's inherit transform. That's it. The hand now translates, rotates, and scales perfectly with the root node. This wraps up the last unique body part for this rig. In the next movie, We'll mirror our left side controls and joints to the right side to create a full rig.